3, 2, 1. Okay, so this next portion, we're going to be talking about what we define a function as and how we can represent functions using different kinds of models. So defining a function, we need to understand what a function is. And it is a relationship that exists between two numbers or variables with the following rule. And that rule is really, really important for defining a function over a different kind of relationship. The rule is for every valid input number, there is a single output number. Or for every x, there is only one y. Now, what this looks like is if I am given a table of values, x and y, 1, 2, 3, 4, 2, 4, 6, 8. Every time there is an x value in this chart here on this side, it only corresponds with one y value. What I don't want to see is something like this. So yes, this is a function. Okay, what I don't want to see when I'm looking for functions is something like this, where I've got 0, 0, 1, 2, 3, 3, 4. Okay, so because our x values are repeated here or doubled up and here, this is not a function. So for every x, there is only one y. This might be 1 and 2. So for this x value of 0, there is 2 different y values. This is just a sample one. So, okay. So if I had this one here, what this is looking like is positive 2 squared is equal to 4, and negative 2 squared is equal to 4. So I'm looking at these values here, whereas this one is going to be the same thing, but I'm going to get the same x value. And so I'm going to have negative 2 squared is equal to 4, which is my x now, not my y. And then I'm going to have positive 2 squared is equal to 4 as well. So the difference here is that my x's are different in this situation, but my x's are the same in this situation. So yes, this is a function, but no, this is not a function. Okay, so there's a few different things we can get, or pieces of information that we can get from this. And so when you're working with these types of problems, you're going to be working with an equation. So we can use the equation that we're going to actually use in our next section, which is y equals 5x plus 3. Okay, and so right away I can look at that and go, okay, my y is not squared, so this is going to be a function. And I could write something out in words where I could say the cost is equal to 5 times, the weight plus $3. Okay, that might be the problem in words. A set of ordered pairs and a table of values will come from actually doing some calculations here. And so we'll talk about that in a second, but remember our set of ordered pairs is our x and our y, and our table of values looks like what we talked about up there. Once we get our set of ordered pairs, once we get our table of values, I should have written this in another order, we can get our set of ordered pairs, and then we can graph it. And so that's kind of the steps. So this is about defining a function and the information that we can get from it. If we want to talk about what we're going to do with a function, we can represent data using function models. And so a mathematical model is a visual representation of math to help the brain see it. And a function model is that exact same thing, but specifically one input for every output, or one x value for every y value. Okay, so using that same equation that we talked about before, I am going to start to solve for my input and output using the table model. And so the first thing that I'm going to do is when I'm given an equation like this here, I'm going to start plugging x values in for this. Now I know that on a graph, I'm able to plot anything anywhere. So if this is my graph, I can plot all along my x line unless there are restrictions. So I'm just going to start with positive values and plugging those positive values in for x. So I'm going to go 0, 1, 2, 3, and 4. And I am now able to calculate that. So I can go through this and start putting this value in for that x. So this then would be y equals 5 times 0 plus 3. And so this would be y equals 3. Okay, and let's do that again for a couple more values here. So then I can look at this guy here. So 5 times 1 plus 3 equals y. Well, y equals 5 plus 3, so y equals 8. Last one I'm going to do here just as a test is y equals 5 times 2 plus 3. So this is 10 plus 3, and then I'm going to be at 13 equals y. Okay, so I can see here that this has gone up by 5, and this has gone up by 5, and so my next one will also go up by 5, and it will be 18, and then this one will go up by 5, and it will be 23. Okay, so this equation has created a table of values, and I've used a table model here. And so just to review for our table model, one, you're going to pick x values when you're given an equation, then plug your x values into the linear equation and solve for y. Then we are going to spend some time graphing. So a graph model is a good way to visually determine if something is a function or not. Now we've talked about how to determine from an equation and from a set of values, but now we're going to do it with our graph. So I'm going to quickly graph the points that I see here. So my first one here, the 0 and 3. So I'm going to go 0 on my x and up to 3. So that's somewhere right in there. And then my next one is 1 and 8, which is somewhere right in there. And my next one was in blue, and that was 2 and 13. So somewhere right in there. Whoops. And this last one I am going to do in green here. And 3 was somewhere about 18, and so that would have been right about here. I am going to draw my line straight through my points. And now I'm going to determine if it's a function using the vertical line test. And if you don't know what that is, this is our handy dandy little trick. What you can do when you're given a graph and you're asked to prove if something's a function and you know it's a complete graph or the pattern is going to continue on, you can draw a vertical line at any point through the graph. So I'm going to draw these 4 lines in red. You do not have to draw this many, but I just want to show you the point. If you draw those lines here and they only cross the point of your line in one spot, then you have a function. So this one passes, check, passes the vertical line test. So just to show you an example of one that would not pass the vertical line test, if you had a graph that looked like this, and you drew a line there, that would not pass the vertical line test. If you had a graph that looked like this, that also does not pass. And the last common one is one like this, and that would also not pass the vertical line test. So these are not functions. Okay, so now in this video, we've talked about representing data using function models, and we've also talked about defining a function and using our knowledge of those different aspects to look at what is or is not a function. In the next video, we'll talk about domain and range and writing those more specifically and clearly for different kinds of functions and not just linear relations.